Please, can everyone get me correctly? I want to know if my mic is connected correctly, please.
Good morning, Fortune. Yes, your mic is pretty good. The voice is clear.
Okay, my mic is pretty good. There you go.
There is quite an echo in your voice.
The echo is still there. I just want to. The echo is still there, Yussuf. Still want to.
Shall we get started or wait like
Yeah,
5 minutes?
yeah. Let's wait just for like 5 minutes. Let's say we are doing the last modifications. So it means you can get me correctly, Yussuf. Welcome everyone. Yussuf, welcome.
Welcome, Fortune. Thanks for having me.
I'm glad to have you back.
Shall we get started now?
Yeah. I think it's better for us to get started. They will come. If I, we'll keep going and they'll be coming. They'll be jumping in.
Okay.
Welcome everyone, and welcome to our first meeting for the Dollar City SOLIDWORKS User Group. Our first meeting in 2026, of course. My name is Donfa Fortune, and I'll be your host for today. We'll be walking you through some tips and tricks to ace the CSWE exam with our certified CSW specialist, Yussuf. Welcome, Yussuf.
Thanks, Fortune. Thanks for having me again. And this is actually quite an important session because
Yeah.
CSWE is actually the hardest. I believe CSWE CAD design and simulation, CSWE simulation are the hardest exams. So you have to prepare quite well for the exam. That's why it's important.
So Yusuf, a quick presentation.
Presentation about me.
Yeah, yeah, about you first.
Okay. So I am Yussuf Hassam. I'm a mechanical engineer from Egypt. I'm actually still studying until today, but I'm actively working as a mechanical engineer as a freelancer. I also have quite a dozen of certifications. The last one of them was Certified SolidWorks Expert and Certified SolidWorks Professional in simulation. So I have quite experience in this certification. And also, this session specifically, uh, I have presented it 3 times actually. This is the 3rd time. So, inshallah, this session will be beneficial for all of you and anyone who wants to go to the CSWE. It will help you. So let's get started. Shall I? I will share my screen right now.
Yeah, please, quick note before you start. If anyone has a question, please just wait at the end of the session before you can just put your question at the comment section, and at the end of the session, Yusuf will come and answer them one after the other. You know, it's for the in fact, Yusuf cannot be presenting and you are just interrupting him all the time. So that's why I'm saying it. So please just make your possible to just try your best to put your question at the comment section, or wait at the end of the session before asking your question, and Yusuf will get to it at the end. So let's start, and the
So
floor is to you.
if there is an important question in the chat, please tell me because I will not be able to see it. Okay. Is the screen okay for everyone? Can anyone see the screen?
Yeah, I can see the screen. I think it's perfect.
So before we start diving into the technicalities of CSWE exam, I believe at this point, all of you know what is SolidWorks certification program is. But I'll start from the beginning. SolidWorks certification program is a program provided by SolidWorks, and it has a lot of certifications in multiple categories. So yeah, you have to search about SolidWorks Certification Center and go to the link. So the certifications is actually can be categorized in multiple ways. The easiest way to categorize it is based on level. The associate level is the easiest one, then the professional, and we can include in the professional advanced exams like sheet metal, surfacing, mold tools, uh, will in the requirements of the exam, he have passed the professional exams and also the associate level. And the second category actually is based on the field. So the CAD design, the popular category is the design slash engineering. This is what it has, the CSWA exam, CSWP, CSWE, sheet metal, weldments, and so on to the end of the list. And also it does have a category like manufacturing, and this is the most popular of them is SolidWorks CAM Professional, and also SolidWorks Additive Manufacturing. And the last category that concerns engineers is simulation, and it has also the same categorization: associate level, professional level, and expert level. So the expert level, either in simulation or design slash engineering category, is the hard hardest one. So this is why you have to prepare quite well for the exam, because passing it is quite hard actually. So let's get to the details of the CSWE. If you click on any of these certifications, all of the information about the exam will be provided. So let's search for the CSWE exam information. So SolidWorks actually defines the CSWE by quite a good definition. A CSWE will be well-rounded in their knowledge of all areas of SolidWorks software. A CSWE is able to solve practically any modeling problem given to them. So this is the highest level. This is the highest level you can get in SolidWorks certifications. There is some important links like recommended courses by SolidWorks. There are recommended and official courses actually by SolidWorks in SolidWorks e-learning platform. And all of these links are important actually, but this session will help you because it is specifically made from someone who passed the exam and knows what is in the exam without actually telling you the exam, you know? Okay. So some important thing is actually the prerequisites of the exam. You have to pass 5 exams actually: the CSWP, CAD design, and 4 of the advanced topics like sheet metal, weldment, surfacing, mold tools, and drawing tools. So you have to pass the CSWP and 4 of these 5. So the total is 5. The exam length is 4 hours, and the minimum passing grade is 80%. So all of these things or tools might be in the exam or might not. Again, the version of the exam does not change quite a bit. Like in the last 5 years, the exam did not change, but it did change in the last 6 months, I believe. But some of these topics will be in the exam, some will not, but you have to study it all. Okay. Anyone have any question to the moment? Okay. So the resource actually I have prepared for this session is a sample exam I have prepared quite back then, like a year ago. And there is actually no official sample exam for CSWE. There is an official sample exams for CSWP and sheet metal and weldments and so on. But for CSWE, there is not an official sample exam. So we can practice for the exam from this sample exam. And we will start to solve each question individually and in depth actually. So let's get started. This is the start of the session. Okay. So let's open SolidWorks and start a part. So the first topic is actually about belt and chain, and it was written in the page. So let's open SolidWorks and start a sketch. So belt to chain actually is a topic in sketch blocks. So you have to know sketch blocks to know how to solve the belt/chain question. We can go click in the command manager, right click, toolbars, and you can activate the sketch blocks from here. And you can drag it and put it in anywhere you want. So you will have to use this in the exam. So a toolbar like this will be helpful in the exam. So let's start by drawing the sketch. The sketch is quite easy actually, 4 circles with a lot of dimensions. So we'll start. And I will also mention some of the tips and tricks so that it doesn't take a lot of time for you to solve the exam. You have to use the mouse gestures. So you can go to options, customize mouse gestures, and you can put the mouse gesture that you want. These are the ones I have chosen, and it shortens a lot the time when I solve a question. Okay, so I'll use mouse gesture to make the circle. And I also I can put the dimension right now, so I don't have to wait until the circle is done and smart dimension and dimension it. No, I can put the dimension right now, 35. And to activate this, go to the options, sketch, and enable on-screen numeric input, and create dimension only when value is entered. Each of these two make it checked. Okay, so 35, 20, 15, and 50. 15 and 50. I will fix one to the origin, and the other ones I will dimension them. Okay, so 30 and 60. 30. And also smart dimension from the mouse gesture, and 60. The bottom one is 60, and these two centers are vertical. So this is 60, and these two are vertical. The last circle, 30 and 100. This is why I put the 20 circle in the origin, because all of the other circles are referenced to it. So if I make it fixed, I will solve this problem faster. Fixed to the origin. Okay, so now the circles are good, the dimensions are good. Now we have to make the belt and chain. So we can activate it from here, belt and chain. And the arrangement actually is important. So I have to choose the circles based on this arrangement, the belt, the direction of the belt. So an arrangement like this, oh, sorry, there is a problem here. Before we get into the belt and chain, we have to make each of these circles a block. And this is actually an error we have, because belt and chain cannot identify sketch entities, regular sketch entities. We have to convert it first into a sketch block. So this alone should be a sketch block. This alone should be a sketch block, and so on. Oh. Okay. Very good. So we cannot see it here, but actually this circle is spinning. This is a property in sketch blocks. The shape is not fixed, so it can rotate about this point. So now we can make a belt. This arrangement, this, and this. And this is flipped. So I can click here and flip belt side. This is the same pattern or the same shape. Now I have to put the belt thickness. Use belt thickness, it is 15. Very good. And I can engage belt. So this is the first question. The belt thickness is 15, and he wants the belt length. The belt length is actually is actually here. And also if I edit the belt, it's actually mentioned there. So this is the answer of the first question, 640.24 millimeters. Okay. So now let's get to the second question. Oh, there was actually some modification to this exam. Yeah. Nearly in all of the questions in all of the exams of SolidWorks, we use something called equations. So we make the first part, or make the first question, and it's often an MCQ question, multiple answer question. So you can get to know if you are right or wrong based on if your answer is in the choices or not. The second question and third question and so on is oftenly an equation question. So you have an equation like A equals 80, and this was the first question. The second question, modify A to 70, and modify B to 75, and so on. So you can easily solve the second and third question if the first question is right. So this was the same thing I wanted to show you. So if we have something like this, where's SolidWorks now? I will edit this. I have to click on the block and click edit block. Edit block allows me to go into the sketch and add or remove something from the block. So I add a circle right there, and also go to this circle, right click, edit block, and also add a circle. Anywhere, it doesn't matter right now. So if I rotate this circle, the second circle also rotates by a ratio based on the diameter of the pulleys. Okay, so what I wanted to do is actually making this with an angle, like, it doesn't really matter, 75. I want to just explain you something, and if this is 75, this doesn't work, so I have to do it this way. 40. If this is 40, then this circle also has an angle. And it's driven, yeah. So if I make this 60, then the angle here changes. 110, and also this angle changes. So this is actually the idea behind the question that might be the second and third questions. So the belt and chain could be 3 questions. Could be 3 questions. And the second and third questions could just be edit the equation or edit this dimension, and so on. So this is the belt/chain question. Anyone has a question? Between each question, I'll just go to chat and see if anyone has a question. So this is the first one. Let's get back. Oh, the second question is actually the 3D sketch. And this could be the hardest question on the exam. So let's see it in detail. So we have to make a 3D sketch, and it tells us he wants to know the length of all line segments. So 3 projections and some basic dimensions. and also angles and so on. The 3 angles there and a height and so on. And also we have the isometric. So we have to make to draw this this question. So how to get started in this question? Actually, there are multiple ways, and the intuitive way actually is going into a 3D sketch and just drawing all the line segments from this projection, from this isometric view. But this would be time consuming actually. And there is also a second problem. If we have a line that is not constrained by a plane, so it is a line in the space, in 3D space, with how many dimensions we can fully define this line? By a length, an absolute length, and actually two dimensions, two angle dimensions, like this. And it doesn't define, it also rotates. So we have, we need a second one, a second dimension, like this, like 50. So each line in a 3D sketch needs 3 dimensions to be fully defined. And look how many segments we have there. So this contributes that this question will take us a lot of time. So there is actually a smart way to solve it. So let's delete this. If we see the shape, we notice that the base shape of it is kind of extruded 80 millimeters. 80 millimeters. And the faces of the side is taking a draft angle, like this 70, and these 70, 70, and 80. So the shape is extruded, and we have like 1, 2, 3, 4 angles for a draft. We can solve it from this perspective. So let's open the top plane and draw the basic shape of the base, which is these basic dimensions. These are the dimensions of the base. Okay. Oops. Very good. So 140, 60, 160, 75, 65. And this is vertical. And we have something like an arc. Okay. And this is 80 degrees in radius. This is 60. And that's it. Is this 140? Yes. So we have the shape. It is fully defined now. Okay. So it is fully defined. Now I can extrude this by 80 millimeters. Now we have a solid body. How can we get these line segments from a solid body? Before we do this, we have to make the draft. So one face, second face, third face, these 3 faces have the same draft angle in this projection. So I'll go to draft, And by neutral plane method, this is the neutral plane, and the faces to draft are these. And the draft angle is 70. No, is 90 minus 70. So it is 20. So 20, and we can show preview. It is the other way. So I will flip direction in the neutral plane. So this is the shape. Yeah. So this is the first three faces, and the second face, which is this one, which is this face. It is also angled by a degree, which is in this case this degree, an 80 degree. And if we when we make a draft, we don't take the 80, we take the what completes the 90, so 10 degrees. And it's not inward like the first ones, it is outward. So we make draft, neutral plane, this one, and this direction will make it outward, and this face, and it will be 10 degrees. We can see preview. Yes. So this is the shape. It is the same. It is the same shape as this projection. Okay. So how can we get from this solid body all of these line segments? So this is the smartest way to solve this question, actually. So let's see. We'll open a 3D sketch, and we need to select all of these edges. So I control select this line and this line and this line all the way to all of the lines. So how can we make it faster? I can open toolbars, selection filter, or I can just click F5 on the keyboard, and we'll make a filter for only edges. So I cannot select a face or a point. I can only select edges. And I can control A for select all, or from here, select all. And now I have selected all the lines. I can convert them, convert entities. So now I have all the line segments. So now I will exit the sketch and go to direct editing. Now I don't need this solid body. I have already converted all of the edges. So I will delete /keep body. I have actually did not delete the body. I did not delete the relations of the body. I have deleted the body without deleting the relations. So this differs from if I just click delete. So if I make this, all of the relations from the body will be deleted also. So I have to delete it using the direct editing command, delete /keep body, because I no longer want this body. These are all the line segments. So I can go to it. Now I want to measure this. So I click Control A and evaluate, measure, or I have a keyboard shortcut. So the total length is this number. Anyone has a question for this? Okay. Oh. So this is the problem. some technical issues here, so I'll just stop sharing for a moment and get back. Okay, let's get back. Share screen. Okay, so I'll just do it again. I will delete this body. Okay, so this is the second question. The third question is actually a modification on the second question. And here we can start in the weldment section. As you know, the CSWE exam can have a question in either of drawing tools, weldments, sheet metal, and surfacing. So you have to be quite prepared in these topics. Okay. So we'll start in the weldments. It wants us to use the last sketch to make a weldment, add a weldment. So the weldment profile is actually custom. It is not in the library, so we have to make a custom weldment profile. So I'll start a new part, and in the top plane, I'll sketch this profile. It is a pipe, 20 and 12. So 20 millimeters and 12. And this is our profile. Now I want to save it. How we can save it? Before we save it, actually, we need to know where is the weldment profile location for SolidWorks. From options, file locations, weldment profiles. So I have two locations. One is in the C, and the second one I have already created on my own on the E folder. So I can use either of these locations. So I need to show you how it is. So weldment profiles. I made a profile. I made a folder called weldment profiles, and there is a custom folder. Any name you want. You have there have to be a folder, and inside this folder another one with any name you want, and inside the second folder the file of the sketch. Okay. So I'll have to save it, and we have to save it as a library feature part. So first I have to click on the sketch and save it. I have to click on the sketch first. Library feature part, and go to my location. And I will call it whatever, exp1. Okay, so this is saved. And the else sign here indicates that this is a library feature part. So we'll close this and go to weldments, structural members. So custom is the name of the first folder, this. And the second folder, which is metric, that this folder that was inside the custom folder, we have it there. And the size, we have the two files we have in the metric folder. So this should be the profile and the question. Now I will add the Wellman structure individually. So there are two conditions actually to choose a segments in the same group. The lines should be continuous or should be parallel. In this condition, in this case, we have the continuous lines. So now we have to add the material, alloy 1060. So material is added, all of the segments is added. Now we need to know the mass of all segments. I can click evaluate mass property or just the keyboard shortcut. So this is the mass. Okay. So this is the third question. Now I will add more weldments and it gets harder. So let's add it. Is it the same profile? Yes, it is the same profile. So weldments, structural member. It is easier actually to modify the structure if all of the segments are in the same feature. If they are divided into two structural members feature, it will be harder to edit it. So I will edit the first one and add a new group and choose these as a group. And I cannot add this because it is neither continuous or parallel. And this is the last one. Let's see. So it tells me there that the trim order is 1 in all of these pipes and 2 in this pipe. So what does this mean? Let's edit this again and go to these two joints, this one and this one. So this pipe trim order is 2, and these two pipes the trim order is 1. It is the same as the question. And this, the trim order is 2, and the trim order here is 1. So the trim order is means actually which pipe will be cut before the other pipe. The trim order is and so on. So it is a coincidence, but this is the question. This is the answer of the question. We didn't have to make any modifications. So what is the mass of the segment indicated by 1? This segment. So I'll just click on the body and see its mass, 37 grams. So this is the answer for the fourth question. Now I will need to add all of these segments except these 4 lines. Okay. So I'll just again edit the feature and go to group 2 and add all of these because they are continuous to the line segments. This is correct. And then add a new group. Add this. And these two are parallel, so I can make it in the same group and add the last one. Very good. So this is the shape of the question. Now we have to see the corner treatment. There are 3 corner treatments. Because we make all of these segments in the same feature, we can edit it easily. So I will just click on the corner I want to treat, this one. And also it mentions that all 3 corners are mitered equally between the segments. Mitered equally actually means that all of the segments in the joint have the same trim order. So these should have the same trim order, either 1 or 1 and 1, 2 or 2 and 2, 3 and 3, and so on. It should have the same number. And this also will make it 1 and 1. And the last is this. 1 and 1. So let's see. Is it the same? It is the same. So mitered equally. So all of them, each one of these pipes take only third of the corner. So this is what it means by mitered equally, or the same trim order. So what is the overall mass of all segments? The material is the same, 1060 alloy. Now we need to know the overall mass. So it is 990. There might be a glitch, so we have to check again. Clicking on all the cut list, 990. So there is no problem. But in some cases, there is a glitch, and you have to just click on all the cut list items and recheck it. Okay, this is the 5th question. So let's see if anyone has a question. Okay. So we have finished the weldment section. So let's get to the spring modeling. And this is considered to be one of the hardest because it is quite tricky. So sorry for this. I'll just mute the mic for a second. I'll just drink something because the cough.
Please, everyone, for those who are asking for the link to the YouTube channel, I'm currently finalizing the YouTube channel, so I'll send you that out when I'm finished with that. Or I'll directly, in fact, I'll send it here, I'll send it. Let me just. Okay. That's for the question when it comes to the YouTube channel. And for the recordings, yeah, of course, you're going to have the different recordings. You're going to have the different recordings, and will there be a BOM exercise in the stream? I think Yussuf will answer that. Yussuf, please take this question from
In the chat.
from Ines Bilan. He's asking, will there be a BOM exercise in the stream?
Uh,
I think he
in
should
the
wait until
stream,
the.
actually, in this sample exam, actually, I didn't include the BOM exercise, but in the exam, it does have a BOM question. It's actually not quite hard, and it does require a lot of preparation. But if you have any question in this topic, I can answer it. Yeah. But in this sample exam, I will not be explaining it.
Okay.
And I will, of course, share the sample exam with you.
Okay. Is it better? Yussuf? Are you better?
Let's continue.
Is it okay?
Okay. So, what is the ways to model a spring? Starting from the easiest, we can make a helix, curve, helix, and like 500, the pitch is 25, and revolutions, whatever, 10 revolutions. So we can make a spring by using a helix, and this is the most basic way. We can add a taper angle, like 20 degrees, like this, and make a sweep on it. So these two ways are the most basic, but it cannot reach us to model a spring like this. So this is considered to be an intricate design for a spring. So how can we make it? This this spring actually, or the path of this spring, is does consist of two curves. The first curve, the light gray line, center line, this line, and the second curve actually defines the pitch. So let's see what I mean. I will first draw this center line. This will be the axis. Okay. These two are horizontal. These are horizontal. Okay. And this is in the middle. And these two are vertical. And the diameter is, the radius is 40. And this is 50. What else? Yeah. And this is 160. Very good. So this is fully defined. Now I have the profile. I will use surface modeling. Revolve surface. And I have this surface. So this is the first surface body. The second surface body defines the pitch. So I just need any way to define the pitch. And because I will intersect the two bodies, I need to make it a surface body or a solid body, but a surface body would be better. So I will draw on the front and just add a basic line like this. And I'll add a second sketch and a second line like this. So this is quite tricky. Well, actually, I will make a sweep from this line, only this line. Is it in the same sketch? Oh, sorry. Sweep surface, not sweep body. Sweep surface, this line, and this is the path. It will make a basic shape like this, but I can make a twist, make a profile twist. I will specify the twist value either by degrees, radians, or revolutions. In my case, I have the total length and the number of revolutions. Let's count how many revolutions. So this is 1. This is 1, 2, 3, 4, 5, 6, 7, 8. So 8 revolutions. So in this way, I define the pitch. So I have something that defines the pitch and something that defines the shape of the spring. Now I have to intersect it. I will open a 3D sketch, and I will go to intersection curve. Intersect these surfaces with this surface. And now I don't need these surface bodies, so I will delete them from direct editing. Now I have the profile. I have the path, sorry. The path for the sweep boss. I will sweep it, and it is a circular profile with a diameter of 10, and this is the path. Very good. So this is the spring. He wants the weight of the part. What is the material? The material is AISI 1020. So the answer of this question is 1978. Okay, anyone has a question?
Yeah, I think Rahman is a little bit stuck.
Yeah, intersection tool, you're correct. Can you recap the surface sweep? Why did you do that? Okay. I need a way to define the pitch of the spring using a body, using a surface body or a solid body. So there is a feature inside of the surface sweep or sweep boss. It is in the options, and it is called twist control. So whatever, and this is actually quite interesting. I will show you what is the capabilities of this twist control. If I have something like this, and this is for a coincidence, is the fourth way to make an intricate design for a spring. If I have a path like this, let's make it perpendicular. Let's make it vertical. And I have a circle like this. 10. So something like this, I can make a spring from it using the profile twist command. So the sketch profile is this circle, the path is this. It's loading. Yeah. So there is no result because neither of them intersect. But if I go to options, profile twist, specify twist value, and make revolutions like 1 revolution, 15 revolution. Look. So this is actually a powerful tool. The profile twist feature in the sweep surface or sweep boss feature. By this feature, I can do intricate designs, and I can also make something like the pitch indicated by this surface. So if it's not clear, I'll do it again. This is the profile, and this is the path, and because it is this profile is swept along this axis or this line, I can control how it is swept, and this control is the twist value. Okay. And so on. Okay, you got it. Yeah, this is smart, but it is not in this question. Muhammad says that can we make a double tapered springs to make this question? It could be if we don't have this small radius, because adding this small radius to an intricate design like two tapered springs will be hard. But this is smart. Okay. So these four ways are the only ways to make a spring. The first is the basic helix. The second is the tapered helix. And the third one is the intersection of curves. The intersection of curves could make nearly all kinds of springs. And the fourth way is the twist value, or the twist value for a sweep. Okay. This is a bonus question. So let's see the next question. Sheet metal.
Sheet metal.
So for this question, actually, we will not make a sheet metal. The part is provided by the exam. So I'll just open it. It's called this. No, it is AP1 step file. So it is a step file. So we cannot. It doesn't have any property of sheet metal. So I cannot flatten it. Oh, I don't have even a tree manager. So how can we deal with this? And this is a strong topic actually in CSWE. Is how do you behave with the imported parts? So the material is AISI Alpha 1020. So this is the material. K factor is 0.4, and he wants to know the X dimension after flattening it. So the problem here is how to convert this part to a sheet metal part. So here we have a strong tool called convert to sheet metal. Convert to sheet metal makes a solid body or an important body and so on, sheet metal part by identifying the bends. So we have to check for the thickness. It is 2 millimeters. So the thickness is 2. And the bend radius is 2.2. And the base of the part or the fixed entity is this one. And I can just tell SolidWorks to collect all the bends. So it identifies 1, 2, 3, and this one, and this one, and this one. So we've checked that it identifies all of the bends. So if I flatten now it's converted to sheet metal. And from here, I can modify the K factor. So instead of 0.5, it's 0.4. And if we didn't modify the K factor, the flatten length will be wrong. So flatten. And let's check if this has the same shape. And the same bend lines, 1, 2, 3, 1, 2, 3, 4. So it is the same. So now it wants the X dimension, So it is the length of this line. So the answer is 286 millimeters. So this is the first question for the sheet metal. Anyone has a question? Okay. So the second question is modification on the imported part or the sheet metal. We have converted it now. Apply modifications to the part, then determine what is the part center of mass. So what is the modification? So we have we see that these cutouts are inserted, so we have to make it. But the problem here is that these cutouts are on a bend line, so we cannot make it easily. So the trick here is just go to sheet metal and unfold it. Unfold this only bend. And now I have a flat face. Now I can make a sketch on it. And after I make the cutouts, I will fold it again. So a rectangular cut, 20 by 10. Rectangular, 10 by 20. And it seems to be on the center line, like the center of the rectangle on the center line. Okay, I believe the center line is in the middle of the bend. So these two should be vertical. So this is 30, this dimension. And it is completed. Now we have to do the linear pattern. 4 rectangles, and the dimension is 30 from the other edge. So I'll make a linear pattern for these in the direction of this edge. Reverse. and I will do 4 copies, and I will just do any number. I will not check the dimension x spacing because it will fix the x spacing. I'll just need to drag them like this and add the 30 afterwards. Very good. So this is the 30, 20 by 10. Yeah. So now I can make the cutouts. And I can just fold again. Very good. So this is the 8th question. What does he want? The center of mass and the material is the same. The center of mass will be these 3 numbers. And this is the answer of this question. Okay. If we bend all the sheets, if we unfold all of the bends and then fold all the bends again, it will have the same answer. So it will be correct. But in this case, this only bend is what concerns us. But we absolutely can do it for all the bends. Okay. So the 9th question is also a modification on the part. So what happened? There is a circle, and a circle for in the tester software indicates that there is a change in this thing. So we see that the number of slots is decreased by 2, and also the width of the slot is also decreased. So let's see how can we do that. The problem is that we don't have a tree manager. So I cannot go to the feature, the cut extrude of this feature, and just go to the sketch and edit the dimension. So this question is actually a modification on an imported part. This is identified by this. So apply modifications to the part, then determine what is the part center of mass again. So how can we do that? The fastest way. So the new width is 4. What is the length? 12 millimeters. So from 12 to 4. So now I will decrease all of the width. Well, I will delete it first. I will delete the middle ones first, these 2. I can delete it easily by using the delete face command. I ensure that I have selected the delete and patch. And right click and select tangency. And also right click again, select tangency. Show preview. It should be correct. Okay, so I deleted and patched the cutouts, so now there are no cutouts in this area. So this is half of the answer. Now I need to decrease the width. Yeah.
I think in the previous question, there was a point with one rectangle, and Ahmed Abdel was.
I can't hear you.
Are you with me? I think Ahmed was right with that. There was there was one rectangle that was missing. It was 5 of them actually, and you just placed 4 of them. That was just for. I think you can go, and I think everybody knows how to do it.
I don't actually send. 5.
Yeah.
Yeah, you are correct.
That was very good, Ahmed.
No, very good, Ahmed. Yeah. No one noticed. This could be easily modified by just double clicking on this number. I'm just dragging again and adding the 30 degrees, the 30 millimeters. Thanks, Ahmed, for this insight. So the answer for that question is these numbers. Okay, let's get back.
There's also a small question by Tamir Rahman. He's asking about the difference between the delete and patch and the delete and fill command.
Yeah. Actually, delete and patch. Well, actually, the behind the scenes between these specific two commands is quite intricate. So for delete and patch, I don't know what happens behind the scene because I haven't actually used it. Delete and fill. I haven't used delete and fill. Delete and patch does work for all kinds of stuff, but delete and fill, I haven't actually used it, and I don't know who uses it, and I don't know what does it make, because delete and patch all does work all of the time. But
Yussuf, let me try. I think the delete and patch command is more of a command that actually closes the surface. Let's take an example of a hole. Let's take an example of a hole where you want to actually close the inner surface of the hole. What you are going to use basically is the delete. In fact, it depends on the context, but most of the time you're going to use the delete and fill command. But now, when it comes to closing surfaces, sometimes delete and patch is better suited for closing surfaces. So, like Yussuf just said, I don't really know what's going behind the scene during the coding. In fact, what they were thinking about, but depending on the cases, delete and patch can be used, and delete and fill can be used. That's for my own knowledge of that.
yeah, but for in my case, delete and patch did work for all kind of things, either solid modeling or surface modeling. Delete and fill, it doesn't work all of the time, and actually the behind the scenes is quite intricate. Okay, let's continue. Now to decrease the width of these two slots from 12 to 4. So the easiest way is move face and make an offset. Right click, select these faces and an offset by 4. So half the distance. This one is okay. Right click, select tangency, and so on. So let's check if this is actually 4. Yes, it is 4. So this should be the 9th question. The same material. And now it wants the center of mass, okay. And this is the answer of this question. Okay. So the 10th question is actually about sketch picture. There is also a photo you inserted in SolidWorks. And let's see what he wants. Use the provided picture to capture the part shown and determine what is the mass of the part. So we don't have any information about these curves, the radius, the total width, and so on. So all of this information is captured from the image. Only so little information is in the question. So we have to insert the picture first. Let's copy it, put it on desktop. Go on front plane and sketch picture. We can search it, sketch picture, and see where is it by clicking on this eye. It should be in tools, sketch tools, and so on. It's hidden somewhere there. Sketch picture. And go to the rook. And now we have the information. Now we have the picture. The only problem is the scale. The aspect ratio of this picture is locked. We cannot, if we unlock it, then the answer, this question will be wrong, or the answer will be wrong. So we have to make the scale with a locked aspect ratio. We can use this number as an indication for the scale. It is the total height from the base of the rook to the topmost circle, 90.58. So we use the scale tool. We will make sure it is on the bottom. And the end of the line is in the top. Okay, so this is 90.58. And I click yes. Okay, so now we have the shape of the rook. Now the only job to make is we trace the edges. So we have to identify the center of this and fix this point. And also fix this. And this will be the axis that will be revolved around. Okay. Now I'll go to sketch, spline, and I will trace the edges. If I can make anything with a line or a curve, then I will use it. Okay. And now I need to trace all the way from the bottom to the top of the rook. But this this way is actually does consumes a lot of time. So there is another way. Let's see. If we go to add-ins and check for auto trace. If we get back to the sketch and double click on the sketch, on the sketch picture, and clicked on the next icon, now we have the auto trace. There is a problem here. I believe this is a glitch. It is a glitch. Yeah, it is a glitch. If I do it again, Oh. So let's see again. There's quite an issue here because the auto trace command does work well, but for this condition, there is a glitch. We click next now. So in this window, there should be the image of the rook appears, but there's some kind of an error. It is so scaled up. It is so zoomed in a certain line. So there is an issue. And I cannot zoom out or zoom in. Whatever. So I needed to explain this to you because this does consumes nearly the fifth of the time if we trace it manually. But this is a glitch. It is a glitch. Okay, so we'll trace it manually. In this question specifically, the error margin for the answer will be large. Like in common cases, it is plus or minus 1%. But if this question is in the exam, it might be like 3% or so on, because the error happens when we try to draw. Okay, now we have the profile. We can revolve it. Is it closed? It is closed. Now we have the shape of the rook. Now we need to make the cutouts. First, we'll make this cutout 14.34. 14.34, and it's written true because any dimension in the isometric view could be true or not the true value. It could be the dimension in the isometric shape on the drawing. So if it is true, then we can draw the circle with this dimension. 14.34, 14.34 multiplied by 2, 14.34. There is a problem. Something is wrong. Is the scale is not correct? We did not scale up. We did not make it. So it is again 1990.58. Okay. So we can scale entities, but the ratio is not known. And also the segments is, but this is a problem. We need to redo it again, or just if we know the scale ratio, we can make it scaled again. But in the part, we can make it scale and just scale it. But this already took a lot of time from us. But so I'll just tell you the process. Because if the auto trace function did work, we could have solved it in nearly a minute. I'll just make a cutout by a depth of 5.5. No, doesn't matter. Now we'll make the rectangles. By any dimension, because this dimension we cannot work with them now. So nearby dimension through all both directions. Well, it should be. And we can make a cut extrude. We can make a circle pattern in this direction for this cutout. Okay, so this is how you can solve it, but we have the issue that the auto trace did not work. Where's the meeting? The auto trace did not work. The function of auto trace that it automatically traces the edges if we have a contrast. So if we have a shape like Batman logo, something like this, it has a lot of contrast. So we have black and white. So it can easily trace the outer edge of the logo. So because the picture of the rope has the same criteria, it does have a contrast, white and black regions. The auto trace command will easily traces it. But unfortunately, it didn't work. So we did. Well, the only way to do it is manually making it, and it will close. A lot of problems in this meeting. A lot of problems. Okay. Anyone has a question? This question messed up a little bit, but if anyone has a question, I answer. Oh, yeah, it's not scaled. We figured it out really late. Assembly modification. Again, the assembly, or for this question, the part will be provided from the exam. So it is AP2. AP2, yeah. So let's see what it wants from us. So we have an assembly. Let's open it. And these are 3 different parts. Okay. So let's see. Make the circular face of P3A, which is this part, always tangent to the faces mentioned. The faces mentioned are these yellow faces. These yellow faces, we need the circular face of P3A to be tangent to it all of the time. Apply modifications if necessary. And after you do it, make a parallel relation between these 2 faces, and apply a distance mate, and we need to measure the x distance from this face to this face. So let's see. Are the mates for this assembly? There are no mates, so we might need to do it again. Yeah. So these 2 faces are coincident. These 2 are coincident. And these 2 are coincident. If you notice, the hole and the pen moves accordingly to this part. So this means that this part is made in the assembly, or it does have an in-context feature. Yeah, it is this cut extrude. It has an in-context feature. So in this part, it does lay on this face. So we'll make it coincident. And these 2 faces are parallel. This face and this face. So I can move it anywhere I want. So the problem here is that we can make a tangent mate for only a face, like tangent for this face and this face, or this one and this one. But I cannot make a tangent for this face and all of these faces all together. So if we make a tangent for this, it will follow only this curve. Follow this curve, and will be tangent to the extension of this curve. So this will not work for us. We need another way. So there are 2 ways actually to make it. I will open this part and go into the sketch of this boss extrude. So these line segments or segments is what makes a difference in the surfaces. So each line segment of these makes an independent surface. So if we make all of these segments a single segment, that will result in a single surface. So how can we do that? This is made by a command called fit spline. Fit spline fits all the segments that you select into a single spline. And a spline is a single segment, so it will result in a single surface. So I'll select all of these. And this is not a closed spline, it is open. So I will uncheck this. And I'll click OK. So if I click on this, it is a single segment now. So this surface is now a single surface. So I can make a tangent relation now to it. So this will move according to the tangency to this surface. So this works. So this is a great solution. What does he want? Make this 25, make the distance from this face to this face 25. And is also there is a note: the drawing does not represent the real position of P3A. So This is normal. So this is 25 now. It wants the x distance from there to there. So this is the answer of this question. So this is one answer. The second way to do it actually, without the fit spline, is by surface. We can direct editing, delete face, select tangency, and we can delete all of these faces. Now we have a surface body. Now we can enclose it again by a surface, boundary surface. Can you select a group? And this is the first. And we can select a group again. This is the second. Now we have a surface. We have the same surface. Now we need to net these surfaces and enclose it. Create solid, merge entities. Now we have the same body. We have the same surface, but with another way. Of course, there would be a problem. We'll redo the tangent mate, and it will be the same answer. 29.6. So these two ways are great and fast to make it. Okay. There is also an important note that there might be one of you that will think of the cam mate, but it will not work because the cam path needs to be closed. If it was closed, then it will work. But if it is an open path, then we cannot use it. The follower, and we cannot select the cam path and open path. Okay. So this is the 11th question. Any problems? Okay. 2 questions left. So question 12 is an assembly in context. We'll make a part inside the assembly. It is also provided by the exam. Okay, so this part is provided. Now we need to sweep a hollow circle on the spline shown. So this part is what we have, and this part we need to create it. And we need to determine the mass of the pipe. Okay. So you cannot make the flexible tubing part easily without making it inside the assembly, because it will be hard if you go to a single part folder and try to make the appropriate tubing for the distance in the assembly. For the distance, the vertical distance or the horizontal distance and so on, the angles is also required to make it correct. So the best way is to make it inside of the assembly, and this is called top-down assembly. So these 3 parts. Now, how can I make a new part? I can click here, new part, and it is generated. I can rename it tube. Okay. So now I can, if I want to edit in this part, I can have to right click and edit this part. This plane is by coincidence, it is in the middle. So it is the right plane for us. I will sketch on it. I have to make the path of this spline, of this tube. And it is a spline. It is a single spline. So how do we make it? The problem of splines that a 2-point spline does require a lot of information to be fully defined. So it is not. We need to make it. We need to make this profile with the lowest points as possible. If we can make it with 2 points, then we'll make it with 2. If we make it with three, then we'll make it 3 instead of 4 and 5 and so on. So I want to make this spline with only 2 points. So I can fully identify it by the least amount of dimensions. So I'll make spline. Spline starts from this line. Okay. So the tube sits on this face. The face of the tube is coincident with this face. So this is the start. So I'll just, in the midpoint, here it is, and the midpoint of this. So this is the spline. We have to show the handles. The control. Yeah. There should be the handles of the spline should appear now. Inflection point. Even the control polygon doesn't. Well, this is a problem. Oh, here it is. Here it is. So it wasn't activated in the settings. I don't need the control polygon, the curvature comp. So these are the handles. I need to make the flexible tube with only these 2 handles. And it has 2 points. Now this, it tells me that the spline or the tube is tangent to the center line of the cylinder. So if we make a line like this, and these 2 are perpendicular, the spline and this line is tangent. The same condition is also here. This spline and this center line is tangent. So still the spline is still underdefined. Now the magnitude of the handle is 10 now, 1010. I can click on this magnitude and click the value. Now it's still underdefined. The last dimension is the total length of the spline, which is indicated here by this 990. So now the spline should be fully defined. Yes, it's written there, fully defined. And the handle is blue, but never mind, this is a glitch. So this is the path. Now I have to make a sweep by a profile. Where is the correct profile? The correct profile means we can get it from the dimensions, the outer circle and the inner circle. 35 millimeters and 50 millimeters. It is the same dimension as this fitting. So 50 and 35. So we will get back again to the part we've made. If we make any modifications to the part, we have to go to edit part first and then make the modifications. So I need them to make a plane perpendicular to it. So to make a sweep, to make the profile I want, and I will sketch on this 50 and 35. And in first place, I could have converted these two edges. Okay, now I have the profile, and I have the path. All is left is sweeping it. So the profile is these two, and this is the path. Very good. So this is the flexible tube. What is the material? PVC rigid. I click material. PVC. So this is the question. Okay. We need the mass of the pipe. So the mass of the pipe is 1,288. Okay, anyone has a question? Oh, yeah.
I think there's the question from Islam.
Islam? Where? Oh, Muhammad. But Muhammad, you cannot mention actually the same question in the exam, but in if you have the same exam as I did, the question of this, the question you mentioned actually has an error. If I am not wrong, it has an error because I don't know what it was wrong until now. So I don't know, because in the exam, this question itself has a big problem. I don't know what happened. Okay. Still the last question. The last question. This is easy actually. Sketch text. So the trick here is that in the front view we have a letter C, and in the side view we have letter E. So how can we make it? Let's see. So we'll just sketch the letter C in a plane. Letters are written using sketch text with 72 points. So I'll just make midpoint line. Make it construction line. And I will text C. Make it in the middle. And the font is 72. Very good. So this is the first one. I will extrude it by any value till now. Now the second one will make it on the right plane. I will just make it in any place, it doesn't matter. And this is E. It's in the middle and it's also 72. Very good. And I will extrude it again. So the trick here is combining these two bodies. There is an important thing we need to make, that these two bodies will not merge. So they are two separate bodies. So we can combine, common, make this body and this body, and we will just get this shape from a view. It is a C, and from the second view it is an E. Okay. So this is the idea of this question. And also, it's important to mention that the exam also have a BOM question, actually like 4 or 5 questions, but all of them are easy, not hard. The assembly or the question of the BOM, the question of the BOM has an assembly that will be provided by the exam. And you need to know topics like configurations in the assembly and configuration in the part as well. And the bill of material, the BOM in the drawings. It is one of the easiest question actually, but it might be tricky to someone who doesn't know how to work with configuration in the assembly. So I believe that's it. This was the sample exam. If anyone wants to take the CSWE soon, this sample exam will be beneficial for him. All of the questions. You need to make sure that you understand the idea behind all of the questions so that you can make it correct and fast, because being fast is an important thing in this exam. Any questions?
Please, I want to make your attention concerning the YouTube channel. The YouTube channel is already completed and I've just shared the link, so feel free to follow the page. I'll be uploading today the different sessions. We had a session with Ali, another session with Prasad. In fact, we have a lot of sessions that have been recorded, so I'll be uploading them. You feel free to come back and watch them. Also, I want to first of all thank you for the presentation, Yussuf.
Thank you for
the presentation. I myself am going for the CSWE exam, so I think I'll have the.
We'll have great news soon, right?
What?
We'll have great news soon. Be a
yeah. I think with this sample exam, I'll go through it again and again, and I hope with this sample exam, I'll definitely pass the CSWE exam. I've never attempted it, so I don't know what can be one of the last tips when it comes to the monitor setup. I don't know, like some difficulties that you have encountered during the exam and all of that.
If you have a second monitor, it will be helpful a lot to extend the window of SolidWorks to the second monitor. It will make like 5 minutes. It will make you faster like 5 minutes, and 5 minutes in a CSWE exam will be a lot of help. So if you have a second monitor, and make sure that you have a stable internet connection for the 4 hours.
Yeah.
Yeah, use for the tips, use the keyboard shortcuts. Make all of the commands keyboard shortcuts and mouse gestures. These actually help a lot and make you model faster. And yeah, there is also a shortcut bar for the S key. This is also a lot helpful.
Yeah. Okay. I have my other students that are coming, so I think for the presentation we can wrap up. I think we can wrap up for the session of today. What do you think, Yussuf?
Yeah, I might need to answer these questions before we wrap up the session.
Okay, no problem.
There is a question about the radius of the imported parts. This is actually a common problem, and if it's not measured or identified by the measure tool, the easiest way is actually manually tracing it, like tracing it with the curve command, the arc command, and manually tracing it and then dimensioning the arc. This is the easiest way actually, because an imported part might lose the parametric geometry of it. Okay. I read somewhere that we cannot go back to review the questions once we've passed them in the exam. Is that true? Well, actually, you are limited to the way you review the questions. You cannot go back to the exam and review each question. Is that right? Is that wrong? And so on. But you can actually do something else. You can go to the virtual tester and log into your account. And for example, for the CSWE, I can click on it and click on this page, your exams. And if I click on the CSWE, there is some kind of an in detail results, like the belt and chain, all of the questions. Like as I said, the flexible tubing question, I did it wrong. So so this might help you, but like for the advanced sheet metal, it was 3 questions. So if you have an error in only one of them, you will not know which one of them, but you will have a general idea of what you've done for the questions.
It's quite helpful.
I believe this helps. CSWP exam vouchers. This is with Fortune. Give them CSWP vouchers, Fortune. CSWP
Yeah,
elite.
in fact, when you'll be available, I'll let you know also. When you'll be available, I'll let you know all, okay?
Inshallah.
Inshallah.
CSWE voucher. This will be hard, actually.
Yeah.
What is the total point and passing point? Well, this was mentioned in the in the certification program. The total points is written here. Oh, it's written here. CSWE. The total points is 190, and the points to pass is 160. Yeah, I believe. Yeah. It is 80%.
So, and let's just ask from where. So I have why usually share some of my, in fact, when I have important vouchers, I share it there. So I'll just send the link. Let me just paste the link here. For anyone who's interested, you can join the group. And when I have anything when it comes to vouchers, I don't know, anything concerning the SOLIDWORKS community, I'll just send it to you. Okay. That's it, I'll just pin it now. So, Yussuf, I think it was a nice session. Thanks for that.
Thanks for having me, Forge.
I
For
hope
more
you are going
sessions in the
I
future.
hope you are going for the. In fact, I hope you have the next session with the CSWE simulation exam. Are you preparing for that?
Well, I'm not. That would be hard.
Yeah, yeah,
For,
I think
for, for the
you
technicalities, simulation is a hard topic actually
yeah,
to explain it well. It
yeah,
does require a lot of technicalities in the science itself of finite element analysis, and also behind the scenes of the SolidWorks simulation. It will be a lot hard, but I will do in the future, inshallah.
yeah. Thanks so much. In fact, thank you everyone for this session. You had some couple of great questions. Like I said, I'll just resume. I just sent the link for the YouTube channel of the Dollar City SolidWorks user group. I just sent the WhatsApp community chat group where you can have important updates when it comes to vouchers and everything. So, well, have a nice, I don't know, have a nice day, and later, see you later for the next session. Goodbye to all.
Thanks for the session, Fortune, and thanks for the participants for your good listening. Goodbye, everyone.
Bye, everyone.